So now we will use these properties to calculate determinant of the matrix. And I give you an example. Matrix A equal, for example, 3, 2, 5, 3, minus 5, 6, and 3, 10, 11. For example. Okay, so the first one, and we want to calculate determinant of this matrix. That is unknown one thing. Okay, let's use the direct rule, the direct approach. So we are moving up. I firstly write down these determinants, denotation of the determinants. Minus 5, 6, 3, 10, 11. Okay. So the first one thing here, we have to define the positive and negative factors. It is positive, negative, positive, negative, positive, negative, positive, minus, plus here. You remember that I have to put here the first one element at the matrix. It goes always with this positive sign, and the other one, to define the sign beside the other one elements, you have just switch the sign. So if you have plus here, so the next one minus and plus. And I want to go along the first one column here. And I have something like 3 times. You remember that we have to take this element and exclude the corresponding row and column, and the rest part of the matrix we have to take as a 2 by 2 matrix for determinant calculation. So we have here minus 5, 6, 10, 11. Next one goes this with this sign minus 3 times. We have to exclude the first row and the second row and the first column, and we have here 2, 5, 10, 11. And the last one, 3. If we exclude the third row and the first column, here we have 2, 5, minus 5, 6. So we have here we have here 3 times. Here we have for 2 by 2 matrix, it is very easy to calculate determinant. We have minus 5 times 11, minus 6 times 10, minus 3. Here we have 2 times 11, minus 5 times 10. And the last one, 3, goes 2 times 6 minus 5 times minus 5. And here we have something like minus 45, minus 60, minus 3 times 22, minus 50. And here we have 3 times 12 plus 25. And finally we have 3 times minus 111. And here we have 3 times minus 115. Minus 3 times minus 28. Plus 3 times 37. And we have finally minus 3, 4, 5, minus and minus plus 84 and plus 111, and all this thing gives 0, 5, 150, but minus. So determinant of this matrix is minus 150. Determinant of the matrix A equal 100 minus 150. I use this red ink to highlight this answer. And now we can try to recalculate this determinant using the properties of the matrices, of the determinants, not matrices. Let's calculate determinant of the A equal 3, 2, 5, 3 minus 5, 6, 3, 10, 11. Look, you can notice that the first column consists of the same element. So if we take away from, for example, from row 1 elements of the row 2, we can have here minus, and it means that we can drop out the first one term here in the previous calculation when they expose these determinants and transform it into the sum of the 2 by 2 matrices determinants. So R1 equal R1 minus R2. And you remember it follows from the properties of the determinants, the determinant of the new matrix is equal to the determinant of the given matrix. So we have 3 minus 3, 2 minus 5, and 5 minus 6. And the last one part is the same of the matrix 10, 11. And it is 3 minus 3, 0, 2 plus 5, 7, 5 minus 6, minus 1. And here we have 3 minus 5, 6, 3, 10, 11. Now look, here we have the same 3 as for the second row and this third row. So we can use the same trick, but we can take from the row 2 row 3, and we have here 7 minus 1, 3 minus 3 minus 5 minus 10, and 6 minus 11, and the last one 3 10 11 is still the same as it was at the given matrix. So we have here 7 1 minus 1, 3 minus 3 0, minus 5 minus 10 minus 15, 6 minus 11 minus 5, and the last one is 3 10 11. Now you remember that if we take here plus minus plus, so this element goes this plus, we can expand this given determinant into the set of the 2 by 2 matrices determinants, but the first two elements we can drop out at a glance because we have zeros here, and they have just only the third one term with sign 3, this sign plus, which is 3 times I'm sorry, here we have the vertical part, 7 minus 1 minus 15 minus 5, and we have something like 3 times 7 times minus 5 minus 1 times minus 15. Since that we have 3 times minus 35 minus 1 minus 15, it is plus 15, but we have minus here, and we have 3 times minus 50, and it gives minus 150. So it's very easy to calculate and to compare this result with previously calculated and find out that they are equal. So we have two different ways of calculation. For example, matrix A is 4 by 4 matrix. 1 2 3 4 2 5 0 3, for example, 2 3 5, for example, and 3 1 2 3, for example. And I want to calculate determinant of this matrix, determinant of the A. Let's calculate it. So look, you can notice that we have 0 here, and viscerally it's clear that we can use these columns for expanding of the matrix. But you can notice that we have 3 and 3 at the first row and at the third row. So we can take away from the row 1, for example, row 3. So row 1 equal row 1 minus row 3, and it is 1 minus 2 minus 1, 2 minus 2 0, 3 minus 3 0, 4 minus 5 minus 1, and we have here 2 5 0 3, and here we have here 2 2 3 5 3 1 2 3. You can notice that we have here minus 1 at the first column and minus 1 at the fourth column. So we can have here, for example, column 1 equal column 1 minus column 4. And you have minus 1 minus 1 0, 2 minus 3 minus 1, 2 minus 5 minus 3, 3 minus 3 0, and we have here 0 0 minus 1, 5 0 3, 2 3 5, and 1 2 3. Okay, now we are ready to expand this matrix, transform it into the sum of the determinant of the 3 by 3 matrix. The first one step you have here to define the sign of the factor which goes in the final formula. So if it is plus here, we have here minus, plus, minus. So minus goes with this sign minus, and we have here something like minus, but don't forget that they have the own minus beside the 1. And now we have to exclude this row and this column, and the last matrix goes with elements of the rest part of the matrix. They are minus 1 5 0 minus 3 2 3 0 0 2. Okay, minus and minus we have here plus, so I can write down here one more again, like with no factor here. Three, 2, 3, 0, 1, 2. Okay, for example, I have here 0 and 0 here. I can simplify this. I can simplify. So I can simplify here something, or I can use the direct rule here, because how can I simplify this thing? I can multiply the rule. Better to use. For example, I can multiply the first one column by number. You remember that if you multiply column or row by number, the determinant correspondingly divided or multiplied by the same number. Depends on multiplication. So look, if I multiply the first one column by 5, column 1 equal 5 times column 1, I have to divide this determinant by 5, so it is by 5, so it gives me 1 over 5 minus 1 times 5 minus 3 times 5, 0 times 5, and I have here 5 2 1 0 3 2, and you have 1 over 5 times minus 5 minus 15 0 5 2 1 0 3 2, and I have 1 over 5. I'm sorry. Look, I have 5 and minus 5 and 5 at the first row, the first row. So look, I can add to the column. I want to vanish one of these 5s here, and it's very easy to do. If you add to the column 1, column 2, so you can see that we can subtract columns and rows and add them, and we have 1 over 5 minus 5 plus 5 minus 15 plus 2, 0 plus 1, 5, 2, 1, 0, 3, 2, and we have here 0, 1 over 5, don't forget, 0, minus 15 plus 2, minus 13, 1, 5, 2, 1, 0, 3, 2. Look, at the first one row, we have just one number, and we can use this row as a basic for expanding of this determinant. But first we have to define sign of the factors. So we have here plus, minus, plus. So 5 goes this sign minus, and we have something like this. I want to use the black ink here, and we have here 5, 1 over 5 times minus 5 times, and 5 goes the last rest part matrix consists of minus 13, 3, 1, 2, and we can cancel here 5 and 5, and we have minus 1 times minus 13 times 2, minus 3 times 1, and it gives minus 1 times minus 26 minus 3, and it is minus 29, but here we have minus, so it is 29. So you can notice, you can learn here to calculate the matrix, the determinants of the matrices with high level of size. 4 by 4, 5 by 5, you can simplify them and use the same expanding rule as we did before. But it's better to simplify them before and to eliminate some elements to to reduce your calculation here. Okay, see you next time.